Hello everyone, welcome back. In today's lesson, we will talk about the specific feature of the Python programming language. Its ability to model objects or classes. Like several other programming languages that are part of the family of object-oriented programming languages, as well in Python, we can model real objects through a specific concept known as object. It is used to hold a set of structured information along with some methods. So let's go over what we use to store the data. Let's get back to the concept of the variable. So we have used variables in our formal lesson to store specific data that we might need for a program. Like, for example, if you want to represent a person, we might need to represent the name through a string, which is nothing but a text, an age, which is an integer, the weight of the person, which can be represented as a float number, and several other features of the person. These data are called simple data because they have a specific value and of a specific type. In other cases, we might need to express some more complex data. Let's take, for example, the address, the home address. In the slide, there is example of an Albanian address system, like rruga Specimale, Palati 67, Kati 7, Apartamenti 3. So this is a classical Albanian mail address. Apparently, it looks like a string with some text. But in fact, it is made of several elements, such as the street name, the number, the floor number, the apartment number, etc. So we can decompose it, even though we represent it as a string, we can decompose it in different characteristics, and each of them, hypothetically, can be stored in a specific variable. Such data is called composite because even though it is represented by several features or several elements, like the street name, the number, the floor, etc., it refers to one specific data, called as well atomic data. So altogether, they refer to a specific item. For example, if we want to model a person, we have different features like name, surname, the birthday and the birthplace of the person, the personal number. Now we know that in Albania, each person has a unique ID called personal number. And in the American system, there is a social security number, etc. So all these variables, even though there are several, are used to express the characteristic of a single person. So they all refer to a specific entity in the real world. What if we want to express the data of two different persons in our application? Okay, one solution, even though might not sound the best, can be having the double of the variables, such as name 1, surname 1, birthplace 1, and so on, and the same for the second person, like name 2, surname 2, birthplace 2, and so on. So it can be a solution whether, so in case the number of items we want to map is limited, say a few. But what if we want to store and to manage a lot of persons? So possibly a list. We have seen in a further lesson how to use lists with different values. One possible solution can be having a list for each feature, for each attribute such as name, surname, birthplace, and so on. So for each of these characteristics, we will have a list of elements, a list of values representing respectively the name, the surname, the birthplace, the birthday, etc. So we might have one list for each attribute. But is it something that we can easily manage? What about if we want to add or remove some elements from this list? We don't have one, we have several, one for each possible attribute characterizing the person. So if we want to add a new element, we should remember to add all the data to all the lists representing the person. So to add the proper name, add the list about names, to add the proper surname, add the list about surnames, and so on. And the same problem while removing elements. So we need to keep a line, several lists holding specific information. But what if we miss something? So suppose that we don't know the birthplace of some of the persons in our list. It is supposed to have a missing value in a specific position, like at position 1, we are supposed to have the data of the person 1, at position 2, the person 2, and so on. But say we are missing the birthplace of the third person. So hypothetically, we don't have any value in the third place. And we will continue, the list will continue with the information of, so the birthplace of the fourth person, which basically will be in the third position. And thing will not match. So the indexes of all these lists will not match. So such approach is very difficult to manage. Do we have any other approach, any other solution? One can be the use of dictionaries. Such use we have seen in the former lesson, where we may have a collection of data with a pair of variable name and value. So for each person, we might have a specific dictionary. An alternative solution is creating classes. So what is a class? The class is an atomic representation of a set of data. So we have a set of variables that belong to an entity called class. These variables, considering the example that we have, can be name, surname, birthday, birthplace, and the class that includes all these variables is the class person. And for each attribute, for each variable, we will have the specific value, considering the specific person. So if we need to manage more than one person, we may manage a list not of variables, but a list of classes. Better, a list of instances. Later, we will see the difference between class and instance. So we might build different classes, one for each person, where each of these classes inside with their respective attribute has the values characterizing a specific person. How we do declare a class? There is a keyword class followed by the class name that we want to use and followed by the attributes of the class. So these variables are called attributes, where each attribute has a specific value. So we define a person with name Elton, surname Domnori, and birthplace Calder. So let it start writing class person let's say name equal to, let's use another, John, surname Smith, birthplace, let's say, let's make it British, London. If we want to use this class, we have to create an instance of it. What does it mean? The class describes is a description of the structure and some of the data. So we can build some or declare some variables which have the same structure as the class person. So we will have P equals to person. What is P? P is called an instance. Let us see it as a variable with a name P, which doesn't have a specific value, rather represents a class. And the class has a specific structure and the values. So in this case, the class person is not just a variable, but is something more complex with 3 attributes, respectively name, surname, and birthplace, and their values such as John, Smith, and London. If we want to access the attributes of such class, we usually use the that notation. So let us print in the standard output the value of the attribute name and surname. So we have created an instance of the class person, and we have accessed name and surname. And as you can see in the standard output, we have the value John and the value Smith. Such a variable, we access such a variable not only in read mode, but as well in write mode, meaning that in the same way we can access those variables to read their value, we can as well change their value. So, for example, p.name equals to Mike. Let's print again the value of the attribute name of the class person and observe whether it has changed or not. And as you can see, the first time, the name of the variable, so the value of the variable name is John. After the assignment, it takes the new value such as Mike. So the class P, so the instance P of the class person, will have different values compared to those initially declared. One other feature in the object-oriented programming is the fact that we can declare more than one instance. So we can declare more than one person, such as P1, let's just print the name, and P2 person. Obviously, these two instances has the same structure and the same values. So whether we run it, obviously, the name in both cases will be John. Those two instances, they do reflect, they do mirror the structure of the class, but they are completely independent. Well, the moment we create an instance of the class person, in the memory space of our system, we allocate a specific area and store the data according such structure. So we make a copy of it. The same we do for the instance person2. These two instances refer to two different memory areas where this information is stored, and they are independent. So if we change any data that the, say, instance 1, like the name, Mike, let's see whether it will affect the second instance of the class person. Mean, next time we create an instance, it will have the values of the original class created or the class that has been changed meanwhile. Let's see. As we can observe, the first output is the name Mike, because we have created an instance of the class person. We have renamed one of the attributes, so we gave another value. We did not rename, so we reassigned the value of the attribute name and print it in the standard output. The second time we create an instance, it will mirror the structure of the class originally created without the changes that might have occurred for a specific instance. And as we can see, the name, so the value of the attribute name, still remains as John, meaning that these two instances are independent from one another. But as you can see, we have created two different instances. We might create as well 3 or 4 or many others, but they're apparently with the same data. So is there any utility having different instances when at the end we are referring to the same person? Not that much. Okay, but what if we want to create another person with other names? So do we have to create a person 1 with specific name and person 2 with other names? No, there is no need. The flexibility of having classes is that for a specific class, we can determine dynamically the values of its attributes. In this example, we pre-assign those values the moment we declare the class, but this is not strictly needed. Mean we can assign their values not the moment we create it or write the structure of the class, but the moment we create an instance of a specific class. So the idea of having a class is having some specifics, how this class should be, what attributes it should have. And then the moment we create an instance, we assign values. So the idea is to have the same structure, but different data. So how we do it basically? The moment that we create a class, so we use the keyword class followed by the class name person. We have the keyword, so we will define a function. If this function for classes, these are called as well methods, but they have the structure of a function, has some input values, name, and output value. And a function is defined with the keyword def, followed by the function name. In the object-oriented programming, we say the method name, and the list of attributes. In this specific case, in it is not just a method, it is the constructor. It is a specific method used to create an instance of the class we are referring to, basically the class person. It has a predefined name, so this is a built-in method, which we need to specify only which are the values that we use to assign to a specific instance and to fill with the data that we need to express the person. Among the variables, there is one in specific which is used as a self-reference. So this self is a variable name. We can use any other name if you wish, but it refers to the object itself. So to the attributes inside the object. So that attribute has a specific task or duty. It is used exclusively as a self-reference. Then the first variable used as a self-reference is followed by the values that we want to assign to attributes. In the following we have the syntax self.name equals to name, self.surname equals to surname. What we are defining? We are defining that we have an attribute called name, and we know that this is an attribute because it is part of the class itself. That's why we need this reference, equals to name. The second name, so the second variable, even though they have the same name of the former variable, the former refers to the attribute of the object. The later refers to the argument of the constructor. Even though they are the same, they refer to two different things. The second is the variable that we have in input. The first is the attribute of the class. So, similar to the previous example, where we had the attributes name and surname, now name and surname cannot be located, cannot be referenced if we don't, or if we miss this auto-reference variables such as self.name, self.surname. The other are the variables names of the method, or in this case, the constructor. What is the utility? Is that we define the structure, so we keep variable their values, so the moment that we create an instance of a specific person, at that moment we provide the required values. Let's take an example. So we have the class person, then we define the constructor self, then let's say A and B. Self.name equals to A, self.surname equals to B. Me and here. Okay. Now, why called A and B? Just to show that these are just variables. You can call X and Y. You can call them my name or input name. You can give the name you wish. These are nothing but the input variables. And input surname. the attributes are these ones. And the moment that we create an instance of a class is the moment we provide as well the specific names for that class. Say, John Smith. In order to see the effect, we can just print in the standard output name and surname and see whether the result is the expected one. Okay, this is John Smith. What is the benefit here? The benefit is that we can create another person with the same class, with the same structure, with the same definitions, but with different values. Let's say P2 Mike White, just some surname. And let's print out what these two variables show. As we can see from the standard output, that the content for each instance is different from one instance to another. That means that we can create several persons, several instances of the class person with the specific value of the attributes. In this case, we have only two, name and surname. In it is a method. It is not just a method. Such method is called constructor and is the method that takes in input some parameters, where the first is a variable that will be used as a self-reference, followed by the variables containing the data that will be assigned to their attributes. So in name is the variable that will hold a value that represent the attribute name, and respectively in surname is a variable holding a value that will represent the attribute surname. What does this method return? This method, because usually methods take some variables in input and returns one variable in output. In this case, such method, such specific method, returns the instance of the object itself. That's why it is called constructor. So it has a specific meaning, a specific task in the concept of classes. So in this case, we have defined only a structure that enables us to provide different items. In this case, we called instances with specific value, but what is important is that they have all of them a unique structure. So if we want to create a person, the only way that we can do it is to provide both name and surname, because the constructor demands two variables, demands two values, describing the entity that we want to represent. So on the other side, suppose that if we have just variables, if we forget to populate one of the variables representing the person, the constructor will remind us that in order to create an instance of the class person, I need exactly two variables representing respectively name and surname. It might be 3, might be 4, it might be 10. So it is a way to ensure that all the attributes are populated according to their respective values, and we don't forget any, so we don't create an instance of something with partially missing data. So we have built an alternative way to represent aggregated data that has a well-defined structure. So person, to use as a sort of analogy, it is like a data type. It's not a simple data type, it's something more complex that holds a structure. It might, a class might have as well some other attributes which are predefined, which do not need any input from the outside. What is required from the user in order to characterize the specific item or instance should be listed in the constructor. So this is all for classes. Next time we'll talk about method or the methods implemented inside the class.